Okay, so let's talk a little bit about formula writing. First thing to keep in mind is that for molecular formulas, you have the number and each kind of atom in the molecule. And for ionic compounds, you have the formula unit, which is the simplest ratio of cations and anions in the molecule. So for ionic compounds, this is usually the trickier one, you have to keep in mind that these ions are charged and you're going to be combining these charged particles. So you have two types. You have the cation, which is positively charged, and the anion, which is negatively charged, okay? So that means you're going to have to be aware of what those charges are when you combine those ions to form ionic compounds. So let's just review. You have to know the charges of the ions. So remember that for group 1, they're all going to lose one electron and form positive 1 ions. And so all of those elements are going to form a charge of +1 when they're in a compound. Group 2 are all going to lose 2 electrons and form positive 2 ions. So you have to be aware of that. Then we jump across the middle to group 13, where they are all going to lose 3 electrons and form positive 3 ions. And so when you see those elements, you know that those are positive 3. Group 14 is tricky because you ask yourself, are they going to lose 4 electrons or gain 4 electrons to fulfill the octet rule? And the answer is neither, really. They tend not to form ions, at least the nonmetals don't. And then the metals at the bottom of the group can actually lose 2 or 4. So those fall into the category of having to be specified. Group 15, again, we're talking about the nonmetals here. They're all going to gain 3 electrons and form -3. Group 15 is going to be the nitride, phosphide, and arsenide. Group 16, they have 6 valence electrons, so they're going to gain 2 electrons and form -2 charged anions. So that's oxide, sulfide, selenide. And then finally, your halogens in group 17 are going to gain 1 electron and form -1 ions. Okay, so you have to remember that pattern as well. Finally, group 18, you guys should know, are stable, noble gases. They do not form ions, so no charge for those. Okay, in the middle now we have the transition metals, and what happens is that they can form more than one possible charge. So we're going to leave them out of the generalization for now. We'll talk in a few minutes about how to figure out what their charge is in the specific compound that you're looking at. Okay, so now let's look at an example. Iron can form +2 or +3 charge. So if it's +2, you would call that iron 2, and you represent that using a Roman numeral 2 to show the charge. And iron 3 would be represented with a Roman numeral 3. So just keep in mind that the 3 refers to the charge on that metal. Okay, so how do we write the formula for that ionic compound? So you would start off, as we just talked about, with the symbol and the charge according to your prediction from the position in the periodic table. So aluminum, let's say we wanted to write the formula for aluminum oxide. We know aluminum is +3, oxide, oxygen is -2, and then we use a technique that we call crisscross. And crisscross just means that you want to balance out the charges so that you have a neutral compound. So you're going to use the number from the other ion's charge to form the subscript. So in this case, that means we need 2 aluminum ions to cancel out the charge of 3 oxide ions. And that means the formula for aluminum oxide is Al2O3. Okay? You only need to crisscross when the charges do not automatically cancel out. So if it's +2, -2, it's just the symbols for the elements. There's no subscripts needed. Simple examples where you just combine monatomic cations and anions Again, if the charges are the same, +1, -1, they cancel out. There's no subscripts. +2, -2, there's no subscripts. But if the charges are different, then you use a crisscross. So here are some examples. If you combine magnesium, which has a charge of +2, with chloride, which has a charge of -1, you will need a subscript of 2 for the chloride. Okay? So just familiarize yourself with different combinations of ions so that you can get as much practice as you can. All right. So what do you have to know? So when you have the two elements, you name the cation and then you name the anion. The naming is actually easier for most than writing the formulas, okay? So you just name the two ions and you're done. What about when there's a transition metal? Now this is a little bit trickier because there now you will have to specify in the name what the charge is on that first element. So in this case, copper has a charge of +1, so it's copper 1 oxide. Here, copper has a charge of +2, so it's copper 2 oxide. Another example, if we had a formula that looks like this, I see here iron with 3 bromides, and I know bromine from group 17 is -1. So if there are 3 of them, that must mean that iron is +3. So then this is iron 3 bromide. There are some more examples here. If you said this first one is iron 2 chloride, you're right. What about the next one? Iron 3 chloride, exactly. What about this one? SN stands for tin. Sulfur is in group 16, so that has a charge of -2. So what must be the charge of tin? If you said tin has to be +2, you are right. This is tin 2 sulfide. So now, if I have this formula with 2 sulfurs, which is a total of -4, then that means tin has a charge of +4. The last two are an exception. Silver, even though silver is located in the same area as the transition metals and the same with zinc, silver only forms a +1 charge, zinc only forms +2, so you do not need to specify the charge. So silver chloride, zinc sulfide. Polyatomic ions. Okay, so you guys have a list of these. I've asked you to guard this with your life. You need this list because I don't want you to have to memorize them right now. This list will help you to identify a special group of ions where the atoms stay together. Okay, so when you see names like 8 or ite, or you don't recognize the name, it's not on the periodic table, usually that means that the ion is a polyatomic ion. So naming is fine, you just look on your list and find the name. Writing the formulas a little bit trickier. You will need to use parentheses if you need a subscript on a polyatomic ion. Okay, so just keep that in mind. All right, so what if we want to write a formula for the following? Silver nitrate. Okay, so silver, as we said, is always +1. Nitrate is on your list. It has a charge of -1, so it cancels out. We don't need any subscripts. It's just AgNO3. Magnesium acetate. Okay, so magnesium is in group 2, so it has a charge of +2. Acetate has a charge of -1. So we are going to need a subscript of 2 for the acetate. Okay, and just remember the formula for the acetate ion can differ. Okay, on your paper I think it's written differently, but same thing. Finally, iron 3 sulfate. So iron in this compound has a charge of +3, and sulfate on your list has a charge of -2. So you have to crisscross, right? So that means iron is going to need a subscript of 2, and the sulfate is going to need a subscript of 3. So you put the whole thing in parentheses and a 3 outside. All right. What about when you want to name covalent compounds? These are super easy. The only thing you have to worry about is making sure that you're talking about a covalent compound. So the difference between an ion, which is the polyatomic ion, and the compound is that the compound doesn't have a charge. Okay, so just keep that in mind. If you have been doing a lot of ionic compounds, you might forget to look out for that. Okay, so this is sulfate ion. This is a covalent compound, which is sulfur trioxide. Okay, so just remember that those are different. One is a polyatomic ion, the other one is neutral, so there's no charge, and you would just name the difference. Sulfide ion versus sulfur trioxide. Okay. All right, so how are we going to name these? You are going to use prefixes for covalent compounds. Very easy. Mono means one, di means two, tri means three. Tetra, you might not remember, it's four. Okay, and then penta, like the pentagon. Hexagon for six, yeah? All right, so you might remember a lot of these from geometry, so it doesn't make it too difficult, but you just have to use those prefixes to tell you what your subscripts are. And that's it. So let's say we wanted to name N2O5. So that would be dinitrogen pentoxide. Okay? And then CO2, you guys would remember because it's something you exhale right now. It's carbon dioxide. But what about CO? That would be carbon monoxide. And then finally, carbon tetrachloride. Okay? All right. So just remember, generally, we don't put two vowels together because it sounds weird. So we would say monoxide instead of monoxide. Okay. All right. Quick review. So how are you going to figure out how to name something? So first of all, is the first element a metal? If it is, yes, you know it's an ionic compound. If it's a transition metal, that means you have to use the Roman numerals. If it's not a transition metal, don't need any Roman numerals. Okay, what about if the first element is not a metal? Then, if it's a non-metal, you know you have a covalent compound, so you just use mono di tri. Finally, we're not going to worry about the acid, so if you see something that starts with hydrogen and you're wondering what it is, just ask me, I'll help you out with that. And those are acids, okay? So if hydrogen is the first element, it is an acid, and we'll work it out together. Hope this was helpful. Good luck.